Welcome, software engineers, to day 16 of CSC 222, Software Engineering. Boss, tell all the work from home people to come in Friday for an employee meeting. How will I explain to them the sadistic absurdity of your request? Tell them we're like a family and I miss them. Does this fall under the umbrella of domestic violence? I missed you also. Thank you very much. By the way, if you're wondering here, you can see how things are in the background. In reality, it did snow. It snowed outside my window this morning. Sometimes we get a little, not this much, obviously, but sometimes we do get some snow in October. Typically, it's just flakes in the air, but I had a little pile on the grass. It is going to warm back up above freezing later this week, so it won't stick. The benefit to California is called winter. Good. You have been working on the Christianity and computer science assignments, and I've appreciated reading your insights into these things. I thank you for allowing me to share them with you. And I thank you also for putting forth some effort and thinking about not only the commandments themselves, and something you may not have thought about before, and that is the positive aspects. Commandment does say, don't do this, but in context, there's always a positive aspect of it also. And then seeing how that might relate to professionalism, and especially us as computer science and information technology professionals. As you saw last time, the CNCS assignment this time is not a commandment per se, but talks about the two tables of the law. I know if you've already had one or more of the required religion classes, then I know you've heard about this. But it's good to think about that also, because the two tables of the law give me an opportunity to investigate really what's at the heart of the commandments. The first three commandments, and remember, Martin Luther numbered the commandments one way, other Christian groups may number it another way. But the first three commandments are the first table, our relationship to God, and the last six, 4 through 10, are our relationship to our neighbor. So those are the two tables of the law. And you'll see on the assignment how that's broken up, and just think about what's the common theme there between those. Love to God, love to neighbor. In the assignment itself, you see a little bit of the response. A couple times in the Gospels, this narrative is recorded where a person who was expert in the law, and realize when the New Testament talks about a lawyer or one expert in the law, it's referring to God's law. Teacher, which is the greatest commandment in the law? And of course, the biblical text indicates that this expert was just trying to trick Jesus. Jesus would have none of it. You shall love the Lord your God with all your heart, with all your soul, with all your mind. This is the first and greatest commandment. Jesus didn't stop there. And the second is like it. You shall love your neighbor as yourself. On these two commandments depend all the law and the prophets. In context, when Jesus says law and prophets, he's talking about the sum total of the Old Testament, the Bible of the time. So with that little bit of background, you'll think about that. I appreciate it. A concept that I know that you're likely familiar with. Concordia universities talk a lot about vocation. The Latin word means calling, but in context, it means how in the world can we do what Christ has asked us to do in various situations? As a computer scientist, what is my, quote, calling? Love to my client and love to other team members and members of my company. Thank you. All right. So while I was gone, I asked you to meet as a team and then do assignment 14.5. Sorry about the 0.5 there, but I just wanted to move some things around, and it's easier when I do this in Blackboard rather than trying to actually change things. So assignment 14.5, that's due today. Thank you for getting together as a team. A couple teams asked, does it have to be in person? The answer is no. You could meet whatever makes sense for you. If you can connect via Zoom somehow, that's great too. Whatever it takes just to meet. At one time, people didn't even think it was possible for a software engineering team to meet online. That's becoming fairly common. I've talked to probably a dozen former students and currently working computer scientists who tell me that, I had just talked to an individual whose job is in the Washington, D.C. area. And during the COVID crisis, they all went online and they haven't really come back. So he asked his boss, can I move someplace else? The boss said, sure. So he's currently living in Detroit and being part of a team in Washington, D.C. So I guess it can be done. Can be done. Good. CNCS 7, the one on the 2 tables of the law, is due Wednesday. And then a new assignment that we'll talk about today, assignment 16. Nope, there wasn't a 15. Assignment 16 is due a week from today. Assignment 16 will also be a team project. Right. So just to alert you, because I know sometimes on Blackboard, it's a little difficult to tell and see what is what. I posted a link on, let's see, where was that? Probably the announcements you'll find on the Home tab about the Microsoft Education Hub. CUI's IT, it's not called support, IT services maybe. It's finally able to track this down, put it all together. So I'm going to ask a favor of you. I want you to actually go there. Read the directions that I have posted. Those are directly from your IT services or IT support site there. You should have an account set up at Azure Education Hub. Logging in there, you log in with your e-number and then your standard password that you access other things at Irvine with. Logging in there should allow you then to be able to access, download lots of different Microsoft products. And what I was hoping for is that you can download a copy of Windows 10, probably a student or individual copy of that. I wanted to test this, but I can't. Your IT services didn't set me up, probably because I'm not a student. So I'm going to ask you, would you please go there, log in, pour through. There should be lots of software available, including Visual Studio, but you can download that elsewhere for free. Would you just everybody, double check for me that you can get Windows? Because that was the whole point. Those of us using a Mac need to have a license key so we can have a legitimate version of Windows running on top of our Mac. Thank you. You can search, this is just from the Microsoft site there about that. So you'll find that as an announcement on Blackboard. Thanks for doing that. It was cold here today. 32 is cold. But as we say, you ain't seen nothing yet. Oh, speaking of that, I didn't want this to sneak up. It is 2 weeks away, but I didn't want it to sneak up on you. Exam number 2 is Monday, the 31st of October, Reformation Day, day 20 in our counting here. Same format that you saw in exam 1, but different questions. This is a unit exam. It'll focus on unit 2. This is the implementation of software engineering unit. Two major phases: design, which we've talked a lot about. I think we'll finish that up today. And then instantiation. So new topics, new questions, but it will be a similar format. The exam will hop in online at Blackboard that day. As the last time, I'll meet with you just a little bit beforehand and then be available in case you have any questions during the exam. There will be something posted on Blackboard. If you can't see it yet, I'll make sure that gets released soon. Just as with the first one, just some generalized questions to help you focus on what was most important for this unit. I wanted to show you this video the last time we met, and I was having some trouble. I couldn't get it to go. But you remember a little while ago, we talked about user errors. And one huge job of a software engineer is to plan for user error. But errors come in a couple conceptual ways: slips versus mistakes. So let's see if I can actually get this to work. Once it starts, I'll switch. I know you can't see it, but let's just make sure. And I'll wait till, oh, what? No commercial? Really? I have to dismiss the YouTube thing. Hang on. Are you ready? Slips versus mistakes.
In UX, we often talk about error prevention. But to prevent errors, we need to first understand why they happen. There are actually two different types of errors that users can make: slips and mistakes. Slips are those silly errors that often occur when people aren't paying close attention to what they're doing. So while they intend to perform one action, they slip and end up doing another, often similar action. Interestingly, expert users are actually more likely to slip, as they tend to perform common tasks on autopilot, opening them up to making these types of simple errors. Embarrassing typos in a text message, hitting reply all instead of just reply, or washing your hands with lotion instead of soap are all examples of a slip. Mistakes, on the other hand, are conscious errors that occur when the user's goal is inappropriate for the current problem or task. These typically arise due to a misunderstanding of the situation, when people have incomplete or incorrect information about the task or the system, and so form a mental model that doesn't actually match the interface. For instance, if someone misunderstood a gray button to mean it was disabled and they couldn't submit the form, but it was actually just a design choice, that would be a mistake. Or if someone backed out of a product customization workflow to get a related piece of information, but then lost all of their work, that's a mistake caused by a mismatch between the user's mental model and the system's true functionality. Preventing slips is mostly a matter of guiding users to stay on the right path by offering suggestions, including helpful constraints and choosing good defaults, and using forgiving formatting. Preventing mistakes relies on fully understanding your user's mental models and expectations and designing with that in mind. We want users to form an accurate and appropriate goal and be able to understand how to use the system to achieve that goal. So do your user research and to understand their mental models. Following design conventions, communicating affordances, and building in ways for users to preview the results of their actions can all help reduce user mistakes. There are also some things we can do that help avoid both slips and mistakes. Support undo, warn users before form errors are submitted, and get confirmation before taking any destructive actions. Lastly, lessen any short-term memory burdens for your users by displaying all the contextual information they may need to complete their task. Design as though the user might be interrupted at any moment and needs to be reminded of what they were doing when they return. Once we understand why people commonly make slips and mistakes, we can better design to prevent those errors from happening.
You'll want to remember the concepts of the two types of errors here: slips versus mistakes. And you'll also note that it's really part of our task as software engineers during the design process to think ahead, consider how might the user err, and How do we trap it? How do we prevent it? How do we allow the user to recover from it? That's one of the tasks among many that make software engineering more challenging and more exciting than merely coding. I want to review some things we talked about before and you read about last week, and the importance of design. The design phase of software engineering is the most important phase. It's often one of the phases that is overlooked or attempted to bypass quickly, etc. Many software engineers find coding much more interesting and exciting. By the way, because why? We can get immediate feedback. Hack out some code, throw it in the compiler, see what happens. But design helps us ensure that what we are building is the correct thing and is built well. I've shared with you this idea. Think of design as the blueprint for instantiation. Your design, that's the documentation and other material that will help the programmer, the coder, actually create the product. When folks design buildings, when people build buildings, they don't immediately grab wood and hammer, etc., and go at it. There'll be a blueprint that puts everything together in the plan. For us, remember that a design is a detailed description of how this product is going to solve the problem. We have to be very explicit with the how. If we had a little more time, and if I didn't like you as much, I would give you a little task to do. Now, I always make my Mech 1 students do this, but mainly they're sitting in class and I can peer at them with this face and they get creeped out and they'll do it. I don't know how to make you do it at a distance, so we'll just pretend, but pretend with me. Imagine that I asked you to write C# code to sort a list of integer values from largest to smallest. That statement, sort a list of integer values from largest to smallest, that's a specification. That's a what. Now, trying to generate the code from that, well, I know you could do it. Professor Tallman may have given you just such an assignment at one time in a previous coding class. So I know you can do it, but you realize how difficult it is. There's a lot of thought and mental effort and blah, blah, blah that goes into all that. Now, after struggling with that for a while, gosh, imagine if instead of giving you the specifications, imagine that instead I gave you the design document to do the same task. Well, what's different? The specifications say what to do. The design document says how to do it. So here's the horrible thing I give to students on the Mech 1 campus, and I do make them actually do it. Write the C#, just do it right now, given this design document. And this design document is PDL, Program Description Language, or alternately called pseudocode. So here it is. Now, you recognize that's not code, that's not C#, but at the same time, it's detailed, and it does express exactly how to solve the problem. I mean, this for statement kind of looks like a for statement, kind of, sort of, maybe, right? Instead of the assignment arrow, you'd use an equal sign here, right, for some of these things. Swap may not be an actual callable method, but still, you would much prefer to have this design document to create the code rather than just that specifications document. I can hear the brain waves. You're thinking, yes, this is much better. Good. That's the point. So if you see that, then you understand the importance of design as a blueprint for instantiation. I had a question. I don't want to spend a lot of time on it, but you created in the last incarnation of the Add Numbers app, which, by the way, is not the last incarnation. There'll be more of that. We'll come back to that. We're going to do a couple team things first and then come back to Add Numbers. But in that one, you had to write to a file. Somebody asked a question about, can I read from a file? You know the answer is yes. And there are a number of different ways of doing it. But given what you know right now, here is some code in that stream reader, similar to the stream writer, that will do this. One of the things that's not very helpful here is it reads an entire file as one string. It just jumps. It just dumps everything into a single string. There's no formatting, no whatever. So here I can grab it, note the method read all text, specking a path to where to find it. And there it is. Right? And now in this little thing, after clicking on show, it's going to read that text out, and it's just going to dump the text into that text box. Just because I had that as a question, share with everybody. Don't necessarily have to do anything with that, maybe in the future, but there you go. You'll give your form a good name, right? Good. On the seventh day, as you know, God rested. Then Chuck Norris took over. I missed that, didn't you? I know you did. Did you miss any of these puns? Zeb. Over the weekend, I went to the wedding of 2 Wi-Fi antennas. Zeke, really? How was it? Zeb. The reception was fantastic. The reception was... I got to look in chat and see who gets an A here. Very good. Good job, Nate. All right. I've chatted about Scrum. I want you to spend a little bit of time investigating what Scrum is. The problem, there are so many resources and so many references, and so many people have a slightly different idea. So we might as well stick to just 2 sources. I'll go there. I will show you a video, or maybe 2. Sometimes it's helpful to see and hear it and then go back and read it. But I want to make sure that you understand what is Scrum, why is it used, how is it implemented, etc. Right? So one place to find out about Scrum is scrum.org. Scrum is a framework within which people can address complex, adaptive problems while productively and creatively delivering products of the highest possible value. Now, there's a lot of buzzwords here, things that would mean something to folks. That lightweight framework, that's updated terminology for what we used to call agile. Okay. Many people point to Sutherland and Schwaber as the co-creators of Scrum, and there's other people have a couple other folks involved there. In a nutshell, Scrum requires a Scrum Master to foster an environment where a product owner orders the work for a complex problem into a product backlog. The Scrum team turns a selection of the work into an increment of value during a sprint. The Scrum team and its stakeholders inspect the results and adjust for the next sprint. Look, here's a picture. Introduction. Oh, this is a happy one. I'll show you what I have on the slide there. So scrum.org, what is Scrum? You should take a look at that. Another place to find out some information about Scrum is at the Scrum Alliance, scrumalliance.org. Again, what is Scrum? Okay, yes. Okay, learn what Scrum is and isn't. Scrum overview. Essence. Scrum is a lightweight, yet incredibly powerful set of values, principles, and practices. You're going to find open debate. Is Scrum an actual software development lifecycle? Or is it ideals associated with the software development lifecycle? I fall into that latter camp, as does Scrum Alliance. Values, principles, and practices. Not a software development lifecycle per se, but always connected to a software development lifecycle. Fast feedback, quicker innovation. It's just amazing all the wonderful things Scrum can do. All right. I gotta stick to my plan. What video are we going to see? So you be sure you know what Scrum is, why Scrum's used, who's involved in the Scrum process, and etc. All right, let's do this one here. Okay. Oh, here, I'll do it this way. Hang on, it's coming, I think. After the ad. Let's just wait for the ad to drop. There we go.
Software is transforming the world, and as it does, new
Oops, sorry.
creating uncertain risks and rewards. Traditional models of development often focus on efficiency over value and apply processes that just don't work. Projects can run over schedule, over budget, and products may be outdated by the time they are delivered to market. What are you to do? Scrum is the answer. Scrum is used by over 12 million people around the world for products big and small. It all starts with the product owner who represents customers and other stakeholders. The product owner drives the product backlog, a prioritized, dynamic list of all the work that might be needed for the product. Work is done by a self-organizing development team during the sprint, a period of 1 to 4 weeks. During sprint planning, based on the sprint goal, the sprint backlog is created. With a definition of done in place, the development team works together to deliver value. Once a day, the development team meets for 15 minutes for the daily scrum to inspect and adapt their progress toward the sprint goal, and to surface dependencies or impediments. So who makes sure that Scrum is understood and enacted? The Scrum Master. The Scrum Master is the servant leader of the Scrum team and helps everyone understand Scrum theory, practices, and rules. As the team works towards the sprint goal, the increment grows iteratively, allowing the team to inspect and adapt empirically based on progress. To improve transparency, the increment can be released continuously during the sprint. At the end of the sprint, the Scrum team invites the stakeholders to the sprint review, where they collectively inspect the results. After the sprint review, the Scrum team runs a sprint retrospective, where they evaluate how they worked and build a plan for how to improve. Scrum provides an empirical foundation for teams, enabling them to deliver more frequently, with higher value and better outcomes to customers. Get higher value from your teams and make your customers happy. Visit scrum.org, the home of Scrum, to
Before we look at this next one, I may have shared with you early on in this class that we were going to do a modified Scrum. When I talk to employers, I always ask this question, and what process do you follow? And I'll oftentimes hear them talk about Scrum. But when you get right down to it, Scrum is really more of a philosophy than it is a process. We saw that process there in the idea of sprints, etc. But it's really more of values, principles, and philosophy. And I have never found a company yet that does what either scrum.org or Scrum Alliance says, this is what Scrum, and this is what you should do, these people, etc. So it's one of those things where, like in most places, a company will choose what we think is going to work, modify some other things, and ignore. I did share with you, I know up front, that the odds of you finding an organization that follows our software development lifecycle, those 6 steps directly, not very high. Using those same terms, probably not. But the ideas and the concepts of a software development lifecycle and the principles and values that come from things like milestones, documentation, and testing, everybody's going to do that. Now, Scrum isn't the only player in the software world today. There are several other major ones that people talk about and sometimes pretend that they actually do. Okay. Let's see if we can get this one to go.
What is Kanban? Kanban is a visual management method for any work that follows a process. It helps you improve flow, reduce lead time, and deliver value faster to customers, improving predictability and quality. Kanban is a Japanese term, which literally means signboard or billboard. The Kanban method by David Anderson adapted Kanban for knowledge work such as software development, IT management, as well as business processes such as procurement, legal, HR, marketing, and many others. Kanban helps you harness the power of visual information by using sticky notes on a whiteboard to create a picture of your work using 3 basic columns: to do, doing, and done. Of course, you can model your exact process that you currently follow. The Kanban method is an evolutionary method that promotes gradual, non-disruptive improvements to an organization's processes. 3 core practices of the Kanban method are: 1. Visualize your workflow. 2. Limit work in progress. 3. Manage flow. The main objective of a Kanban system is the smooth flow of work from start to completion without unnecessary slowdown or stoppage. By reducing the work in progress, Kanban helps reduce multitasking and encourages completing the work in hand before taking up anything new. This helps improve overall system flow. It helps reduce delays, reduces time to market, deliver work early and often, helping your organization become lean and agile. Hope you like this video. Please like, share, comment, and most importantly, subscribe to.
So Kanban is really just some ideals and principles. And again, like Scrum, not so much a software development lifecycle per se, but just some ideas to help merge and, in their view, get things done better. Kanban is, although there's software to do it, I mean, the organizations I've seen do it will literally use sticky notes on a board. Most folks believe that the best idea to come out of that is, I think it was the middle one that was shared, limit work in progress. In other words, software engineers should not be multitasking. You should be focusing on a particular task at hand. Okay. Come back. Come back. I know you can see it. I can't. There we go. Do you want some advice? Nope. Advice is just ego and ignorance disguised as helpfulness. Then how will I hear myself talk? The supply cabinet has an awesome echo. Speaking of that, it must be time to stand up. You were standing up when we did not meet, right? Good, good. It must be time. So synchronize your watches. You're going to, how long do we stand up for? A minute? Wow, it seems like a lot of downtime. Okay, you ready? Go. Stand up. I'll just turn off the vid. Are you tired of the snow? Oh, wow. Yeah, I'm tired of it. All right, stand up. Ugh. Feel free to walk around. Come back in 1 minute. 1 minute. Okay, how much more time we got? Anybody taking track of this? I'm just sort of making it up. You're saying 15 more seconds. Okay. All right. And we're back. Thank you. If I was there physically with you, it would be fun to bring in guest speakers. The next thing I try sometimes is to find little videos that talk about what software engineers do. I think they make this stuff up though. Anyway, are you ready? Let's take a look at this. I think it has value. We'll see.
What impact do senior engineers have? Well, how much time do we have?
The title itself is not so important here. It's about the essence, it's about the content.
The responsibilities of the senior engineer are to lay it out and say, this is what I think the system architecture needs to be to solve this problem.
You do focus on solving problems, coding.
We think about things like, how will this project work if we have millions of customers?
If you, as the senior engineer with the most experience, can't solve it, who's going to solve it?
There's definitely a variety of hats that you do have to wear as a senior engineer here, which is incredibly different from other companies.
They're much more being collaborative across teams and solving some of the harder problems that take a longer period of time.
You should be doing a lot of code reviews. You should have your ear to the ground so that you're ahead of the curve on developing technology.
They look at not just today's problems, but at what it is that could help us tomorrow.
Developing a sense for connection between the deepest technical decisions you're making and what the customer is doing. This is another thing that senior engineers need to model on the team.
Mentorship is one really large topic in Amazon, and as a senior engineer, it's always on the front of your mind.
You are the technical leader for a medium to large group of people who are really reliant on you to help them figure out the right things to do.
I think it's all part of the senior engineering emphasis on being a value multiplier rather than just a simple value adder.
Amazon is not one gigantic company. It's a group of smaller companies with very different products that you can focus on.
We're a culture that likes debate. We like to stand at the whiteboard together.
You work around some of the best people in the world.
Engineering management is largely composed of people from an engineering background.
It's a very big space with lots of opportunity.
You're in charge of your own career.
Every day I come to work and I know that there is going to be a challenge that's bigger than I'm used to, that's bigger than me, that's bigger than I've ever designed for.
I've been forced to grow, even in areas and directions that I didn't think I needed to. And being able to do that further into your career is unexpected and really addicting.
It's great just for knowing that there are a huge number of people out there who depend on the systems that you've built.
Things that you work on here at Amazon, customers are going to see them, they're going to use them, they're going to give you feedback on them, and we want engineers who want to work in that world.
Yes, it was definitely an ad, but I think you saw some of the same ideas that we were discussing, especially this connection to the user and the user's problem. And then I know it's focused on senior software engineer, but the idea to look ahead and try to understand and anticipate what's happening. A part of design revolves around the user interface. We're using design not only for the high level and architecture and detailed design of the system software, but design also applies to the user interface. How does the user interact with our tool? That is also a huge part of design. So by user interface, how the user and the computer interact. By definition, an interface is a go-between, something that stands between two parties, facilitating communication. The user interface is what stands between the human user, the client and the user, and our software system underneath it. There are lots of design principles that can be applied to the user interface. Early on in this class, when we were talking about add numbers, I shared some of those with you, tried to force you down a path and a road, separate the input from the output with our command buttons, etc. Believe it or not, there's actually a fairly decent .gov website. You know, .gov is the top level domain name of United States governmental things. Usability.gov. Sometime we'll go there. Do I go there now? I guess I can go there now. If you browse to usability.gov, user interface design basics, anticipating what users might need to do and ensuring the user face has elements that are easy to access, understand, and use to facilitate those actions. UI brings together concepts from interaction design, visual design, and information architecture. And there's actually a fairly good overview of what we mean by both user interface and a topic we'll see in just a little bit, user experience. So I know, I find it weird. And this is sad, isn't it? Yes. Archive no longer updated. Yes, because you need to go to digital.gov, which all right, we will do that, but there's a reason. UI design is also influenced by interaction design. Interaction design. What is user interface design? Designing the user interfaces for users. Users judge designs quickly and care about usability and likability. They don't care about your design, but about getting their tasks done easily and with minimum effort. Your design should therefore be invisible. Users don't focus on it, but on completing tasks. That's a tough thing to hear. I mean, we're going to spend some time designing the user interface, but the less obvious and here's my analogy. The IT support department, their goal is to be invisible. They're doing their job if nobody thinks about them. If nobody thinks about them, that's because all the technology and all the infrastructure is working well and right. When things break, suddenly people say, where's IT support? Right? Yeah. So you want to focus on the user and the user's goal, then you're doing the job well and right. All right. We're going to come back to this, but it fits in this unit. However, we won't have the opportunity to experiment with it until the third unit of the class, but it fits right here. So that's okay. This is a good time to introduce it and to begin thinking about it. And then we can actually put it into deep practice in Unit 3. What are some characteristics of the user interface? What do people strive for? What are considered to be the good characteristics of a user interface? You'll hear words like natural. What's that really mean? Professional. Friendly. Easy to understand. Efficient and concise. Each of these terms has a meaning in the context of user interface. And the other thing that's interesting is it's sometimes some of these might be at odds with each other. Consider professional and friendly. Well, it's not saying that a professional can't be friendly, but those usually carry with it different connotations. And sometimes concise and easy to understand might be at odds. I need some more text or some more information here really to understand what's happening. What are the principles that UI designers follow? Visibility. Ensuring that all actions are visible to the user. Feedback. Anytime the user does something, there should be feedback. I'm sure this has happened to you too. You click on something, you wonder, is it doing something? Did I not click on it? Do I have to click it 29 more times? Let the user know. Constraints. And at the same time, this isn't a playground. It's not a free-for-all. Do things that focus the user on the task at hand. That's useful. We saw that in the video on slips and mistakes. Providing those constraints is a great way to reduce errors. Mapping, and this relates to something on the video, affordance. We'll come back to that idea. Consistency, I'm sure that makes sense to you. If on this screen I do this to move forward, on the next screen, I want to do the same thing to move forward. The idea of an affordance. An affordance is an image or model that gives the user insight into function. An image or model that gives the user insight into function. Today, if you put a button on a form, I think most users know what to do. We're going to push that button. So if it's a touch, I'll push it. If it's not, I'll use the mouse and click on it. Button affords pushing. Related to UI, user interface, is the user experience. This is a bigger and broader concept. User interface refers to what is there. User experience, as the name implies, is how the user feels about the system. Yeah, it's all about the feels. How does the user feel about using this system?
We joined the Wix Partner Program and our company absolutely exploded. We grew the company by 200%.
Hello! Welcome everyone. In this video, you're going to find out what UX design actually is and what it's like to really be a UX designer. Really? I'm Dee, a senior product designer here at AJ & Smart, and I've been working in product design and UX design for over 10 years. In this video, I'm going to actually look through on my computer and show you some real examples of good UX and bad UX, what UX design actually is and how it's defined, and then look at some specific things of what UX designers actually do every day. So as you're watching this video, if you have any questions about UX design or what it is, pop them straight in the comments under this video. Okay, so first things first, I want to look at what UX design actually is. It's a really misunderstood field. So I found this great image online that shows the experience of eating cereal. And you can see here in this image that you've got a product, an interface, and a user experience. You've got the whole experience of actually eating a bowl of breakfast cereal is what the user wants to do and does. They want to eat their bowl of cereal. There's lots of factors in that. The crunch of the cereal, the size of the bowl, the spoon, and if it holds enough stuff, that's the user experience. The other things that we can design make that experience better for the user. The important thing to know here is that the experience exists already for the user. And our job as UX designers is to make that experience better. A lot of people confuse UX design as we're designing what the user's experience should be. That's not what UX design is. There's already an experience there, and we can look at the behavior and the patterns and the habits of people to make their experience better. So I've just given you a definition of what UX design actually is. There are lots of factors involved with UX design, but the three most important ones are on my screen again, that as we're designing something, it needs to be useful, it needs to be usable, and it needs to be desirable. And if we nail all of those three things, then we've designed great user experience. An example that I've brought to show you live is these two coffee cups. They're both designed to fulfill a purpose, which is putting coffee in them and drinking them. But one has good UX design and one has bad UX design. Do you know which one? I'm going to tell you. So if we think about usefulness, usability, and desirability, these cups, we can analyze these things in these two cups. So this one, for example, is useful. Yes, I can put coffee in here. It's a vessel, it will hold the coffee. This one too, actually. Coffee will go inside. But if we look at this one and think about usability, I've got a double layer of glass with air in between, so it's actually insulating my hand from the coffee, so my hand stays cool and the coffee stays hot. That's really usable. It's super easy to use. This one, on the other hand, when I'm holding it, it's kind of actually a little bit difficult to hold by this tiny handle. Like I can get 2 fingers in there, but actually then it's not that easy to hold. And then maybe I'll hold it like this because that's easier, but now my hand gets burned and hot from the coffee. So this one is not actually so usable. And then if we think about desirability, if I see these two products on a supermarket shelf or in someone else's home, which one do I think I'm going to be more attracted to and say, oh, I think I want to buy that one? Which one is sexier? Definitely this one, right? So if we think about usefulness, usability, and desirability, this one nails all three, and all this one is good for is the functionality of holding coffee, and it's not actually that great to use. Look at all the products around you in the world and think about usefulness.
Okay, good enough. I think you can get the idea there. In the last video, she mentioned 3 attributes. In actual fact, most user experience designers do this one. It's a famous honeycomb of 7 attributes. So you saw her talk about useful, usable, and desirable at the top there. And then those are usually added to valuable, findable, credible, and accessible. But that's a lot. And I think if a good software engineer focuses on usable and useful, they're doing a great service. I think desirable may be somebody else's job, but I think accessible could be part of ours also. Useful and usable, absolutely. And those are not the same things. You saw that on the video. Not exactly the same thing. What are some characteristics, as we think about objects, some usability characteristics? Well, in the world of software, we want tools that are productive. You can get more work done in less time. You want to get the work done faster. We're looking for productivity. A system that does not provide productivity will probably not be as usable for the user. Why would I spend more time using your system when I could spend less time using a different system? A second characteristic of usability is efficiency. Efficiency deals with issues of accuracy. Engagement. Do the users like to work with this product? Can the product tolerate errors? In software engineering talk, is it robust? And can it be easily learned? These 5 characteristics are the ones that software UX designers focus on a lot. Is it productive? Is it fast? Is it efficient? Is it accurate? Engaged, tolerate errors, or robust? Ease of learning. All right. Yeah. We're not gonna, we'll come back to that. Come back to that. Online at Blackboard, you will see homework assignment 16. Let's jump over there. Let me jump into Blackboard. I might even be able to find it. I'm not sure. I think it's somewhere. In my listing of 1,000 tabs, I bet it's somewhere. Here it is. So here we are in Unit 2. You note it does end on the 31st of October. That's the date we'll have exam number 2. Assignment 16 is designed to be a team development project. I want you to create a proof of concept. Let's review what that is. A proof of concept is down and dirty code that just demonstrates that something can actually be done. Our goal here is we are not worried about anything we just talked about in the world of user interface or user experience. We're doing this for ourselves to prove that something can actually be accomplished. In the teams that you've been assigned, I want you to create proof of concept code that uses an API. An API. We'll come back in just a minute and we'll talk about what an API is. And I also have a document here with some more information. An API is basically an external site that provides some methods that you can use. So rather than using like a built-in Windows method to print locally, using somebody else's method in the cloud to do something with. This app will be simple. The coding, very straightforward. User interface, very straightforward. You can just request one piece of data. User enters a value, gets one thing back, or maybe just a single command. It just returns one thing. The hard part here is understanding what an API is, finding an API, and then connecting it within your project. Those are the things that need to be done. All right, let's look at APIs for just a minute. What's an API and why does it matter? And, you know, this focuses on social media. That's okay. Your internet experience runs on APIs. But what is an API and why does it matter to you? API stands for Application Programming Interface. Concept in software tech that essentially refers to how multiple applications can interact with and obtain data from one another. APIs operate on agreement of inputs and outputs. Okay. Helpful analogy. Ordering a drink at a bar. Well, how about ordering a drink at a fast food restaurant? Good. When you step up to the fast food restaurant, you're given a menu with several drinks listed. To look at this is like an API. The menu as it's presented to you is the interface. All the drinks listed on the menu are what the fast food restaurant has agreed to serve. When you ask for a certain drink, you receive it. But if you ask for something off the menu, okay, bad. I have this and some other ones listed for you so you can reference those. Rather than me reading it to you, how about if we watch the video? Are you up for that?
Connectivity is an amazing thing. By now, we're all used to the instant connectivity that puts the world at our fingertips. From desktops or devices, we can purchase, post, pin, and pick anything, anywhere. We are connected to the world and each other like never before. But how does it happen? How does data get from here to there? How do different devices and applications connect with each other to allow us to place an order, make a reservation, or book a flight with just a few taps or clicks? The unsung hero of our connected world is the Application Programming Interface, or API. It's the engine under the hood and is behind the scenes that we take for granted, but it's what makes possible all the interactivity we've come to expect and rely upon. But exactly what is an API? It's a question everyone asks. Okay, not really, but we're glad you did. The textbook definition goes something like this. In computer programming, an application programming interface, API, is a set of routines, protocols, and tools for building software applications. An API expresses a software component in terms of its operations, inputs, outputs, and underlying types. Okay, to speak plainly, an API is the messenger that takes requests and tells a system what you want to do, and then returns the response back to you. To give you a familiar example, think of an API as a waiter in a restaurant. Imagine you're sitting at the table with a menu of choices to order from, and the kitchen is the part of the system which will prepare your order. What's missing is the critical link to communicate your order to the kitchen and deliver your food back to your table. That's where the waiter, or API, comes in. The waiter is the messenger that takes your request or order and tells the system, in this case the kitchen, what to do, and then delivers the response back to you, in this case, food. Now that we've whetted your appetite, let's apply this to a real API example. You're probably familiar with the process of searching for airline flights online. Just like at a restaurant, you have a menu of options to choose from. A drop-down menu in this case. You choose a departure city and date, a return city and date, cabin class, and other variables. In order to book your flight, you interact with the airline's website to access the airline's database to see if any seats are available on those dates and what the cost might be based on certain variables. But what if you're not using the airline's website, which has direct access to the information? What if you are using an online travel service that aggregates information from many different airlines? The travel service interacts with the airline's API. The API is the interface that, like your helpful waiter, can be asked by that online travel service to get information from the airline system over the internet to book seats, choose meal preferences, or baggage options. It also then takes the airline's response to your request and delivers it right back to the online travel service, which then shows it to you. So now you can see that it's APIs that make it possible for us all to use travel sites. The same goes for all interactions between applications, data, and devices. They all have APIs that allow computers to operate them, and that's what ultimately creates connectivity. So whenever you think of an API, just think of it as your waiter running back and forth between applications, databases, and devices to deliver data and create the connectivity that puts the world at our fingertips. And whenever you think of creating an API, think MuleSoft.
Yep, couldn't stop it soon enough. APIs are used continuously. As a matter of fact, you have worked with, oops, let's go back. You have worked with an API. You've worked with a number of APIs. Windows provides an API. It provides methods and functions that you can call. Now, the difference between the Windows API and external APIs is the Windows API is right there localized on your machine. So calling it is a pretty straightforward process and built into tools like Visual Studio. If you want to deal with an external website's API, then you have to know some things about it. You have to know about the interface and how to connect to it. That is really the task that I want you to investigate in homework assignment 16. Go down. Yeah, there you go. There we go. There are lots of different APIs. If you do a cursory search, you'll find, for example, APIs that will allow you to query various financial markets and return prices of stocks. If you know a stock ticker symbol, like General Motors, you can type that in, and then the service, the waiter will take that, send it to the site, and then it will return to you the price of that stock. Some of you know these financial, this is not going to happen in real time. There's a delay involved with that, but for our purposes, that's quite okay. You'll also find a number of numeric APIs. For example, you can send it an integer value, and this API will compute the first X Fibonacci numbers in the series, for example. Or my favorite is the various Chuck Norris APIs, real thing. You can query them for the latest Chuck Norris fact, a random saying about Chuck Norris, etc. I want you as a team to create a vision, just like we've done before in Visual Studio, C#, Windows Form app. I want you to create one that connects to and works with an API. You can use any external API. Pick anything that you like, but you're going to have to find one. That's part of the task also. Okay? I want you to work as a team. Decide how to divide up the work. Now, you're going to discover, if you don't already know, how difficult this is going to be because of communication overhead and because of the fact that you can't always serialize the task. I have some examples here. Perhaps one member looks at various APIs. So somebody starts investigating, well, where do I find an API and what are they, etc. Somebody else can investigate, how do I install the API and get it to work in my project? Somebody else can actually create the proof of concept code. Somebody else can create the documentation. You don't have to do that. You can divide it up in different ways. And alternately, everybody can work on all aspects of it, and that's just fine too. Now, in addition, as before, you created some code and you uploaded that to me. I need more than that this time. I want you to produce a document that describes exactly how you solved that problem. Where did you find this API? How did you connect it to Visual Studio? How did you call it within Visual Studio, etc.? This time, I want you to upload your entire complete project folder as a zip file. So you know how it goes. You give it a name and then there's another just zip up everything, upload everything. I'll need to see it all in order to recreate what you did there. Connected here, I have a little document with some sites with some more background information. And after you've taken a look at this, I'm going to encourage you to kind of get together before next time as a team somehow and just see if you've got any questions after you've looked at this material. Next time I want to show you, I'll show you the results of me connecting an API to it. All right. So this is assignment 16. You'll find it online at Blackboard. Giving it to you today. It's due a week from today. It is a team assignment, so I do want every member of the team involved in the process. When you comment your code, where do I have this? Each member should be involved. In the comments of the code, I want you to include all members of the team. Oh, here it is. Thank you. Include an initial comment with the purpose of the app. List all team members, those that were there and actually participating. And hopefully that's everybody. The first person listed on that thing that I posted on Blackboard is the team lead. So that's the person that should be charged with getting everybody together, etc. Sound good? Nope. Sounds like more work. Okay. I agree. CNCS 7 is what we're doing right. Is that right? 7 what we're doing right now? Okay, good. You're working on that right now. Thank you. All righty. The hard part of assignment 16 is not the code and not doing the Visual Studio product or even understanding what an API is. It's the actual nitty-gritty of connecting it, installing what you need to install locally such that you can communicate with a remote server somewhere. Woo! All righty. Team leads or somebody on the team, get in connection with everybody else. And please meet before next time somehow. If it's texting, if it's email, if it's on Twitter, I don't care. Just meet somehow. And then look at the assignment, ask questions. If you can't figure out what I'm looking for, then you can ask next time when I show you. Sounds good. All righty, folks, believe it or not, we've actually bumped up against time. Do we ever go the entire time? Sure we do. All the time we do. All right. Let me stop the recording, and then if you have a specific question, I'll be hanging here for a little bit. Thank you so much for your rapt attention today. Have a happy day. Have a wonderful Tuesday. I'll see you on Wednesday.